Hey everyone, welcome to another system design video. In this video we will be working on parking reservation system. So without wasting any time, let's start. First, we'll go through the requirements basically. Uh, what are the different requirements we need? First is um, the the user should be able to reserve a ticket. User can reserve a ticket, reserve a parking. Then what is this? Get ticket from parking. So basically, parking ticket. So by parking ticket, I don't mean like getting a parking for getting a ticket for parking at a no parking sign. Basically, the receipt, the parking receipt. Then the system should be highly consistent because you need to make sure that the parking that you're trying to reserve is actually free and not reserved by someone else. There should be no overlap. Then types of vehicles. Yeah, we can note down types of vehicles, or types of parking. Then we have to note the parking rates. We also have to get an endpoint which can fetch all open parking, etc. I think this is it. Like for the requirements at least, this is it. So what we can start with is endpoints. Did it like expand on the whole thing? So I'm sorry. There we go. So let's start with endpoints. The first endpoint is reserve. So we should be able to reserve a parking. The parameter it will take is garage ID. So reserve a parking garage ID, then a parking ID. So parking slot ID basically. Then we need to mention at what time this particular reservation should end, right? It will be mentioned by the user. So end time and start time will be calculated at the time of reservation. And yeah, that's it. Oh, no, vehicle type. We can also mention vehicle type. So reservation will take vehicle type. That's parameter. What will it return as? What will it return? It will return reservation ID and expiration time. I think like end time doesn't need to be returned because we are already sending it, so we already have it. It doesn't need to be returned. We don't need to return anything. The reservation ID should be more than enough. Next endpoint would be payment, like where location where you can pay, right? Parameters would be reservation ID, because we can track which reservation you have paid. And for, I think this can be done by a third party. Like we'll just send the reservation ID as the ID by which you can track everything, and payment to be done by a third party. Next endpoint would be to cancel. What will it take? It doesn't need vehicle type, it just need a reservation ID. And once we have a reservation ID, we can just get the garage ID, the parking ID, the end time, the vehicle type, everything. And it will return 202, okay, if it's cancelled. Otherwise, it will return something else. Then what else? What else? Then calculate fare. So that will take, let's say, wait, that it will take garage ID, or we can just take reservation ID. Okay, we'll just pass on reservation ID. Once it has reservation ID, it can always take the database for the garage ID, and from the garage ID, we can get that garage's fares, right? Then free spots. That will take not reservation, the garage ID. I want to check the free spots in a particular garage, right? So that will be that. Then allocate a spot, reserve a spot. Reserve would be an endpoint. So allocate spot would be to basically reserve will call allocate spot to and that will operate on the garage ID. It will ask the garage to allocate a particular spot. What is parking area, parking ID? Because we'll show the parking ID and everything here, right? Like in the user's view, it will show all that. Allocate spot. Oh, by the way, this takes. We have to mention return stuff. Wait, this will return fare, total fare. Garage ID, free spots will return a list of what will it return? List of parking IDs, and allocate will return success or not, right? Success or not. Next is I think your helper functions like wait, why did it? So wait, let me do one thing. We just quickly move this here. So now I can see everything altogether. And one last few more things would be create account if anyone wants to store their vehicle type, and because they are reserving something or reserving parking space all the time, then they can create their own account. Params would be email ID, email ID, username, password. Like I'm not asking for them for the last first and last name. This is just a simple one. And next would be login, which will take username and password. Password returns success of India. I can't see it because of that whole low font thing. And this one will return user ID. I mean, if there is a create account, then there has to be an account where, it should take vehicle type as well, right? It will take vehicle type as well. Vehicle type. Yeah, there we go. These are all your endpoints. Okay. Okay. I'm not able to see it because thanks to this, it should be visible now. All these endpoints we'll need this to make sure that everything is running. Now let's talk about databases. First would be the reservation database. What will be in reservations? Basically, garage ID. You're taking garage ID, then you're storing the parking ID, parking spots ID, then the start time, end time, and whether it's paid or not, which is a boolean. Yep, that should be good. Reservations done, garages, then garages will have a garage ID. Wait, this will also have a reservation ID, right? I'll just to mark the key with the equal sign. Okay. Reservation ID. And this will have garage ID, the park. Okay, one garage. This is good. One garage can have multiple parkings, but do you want to store every parking? No, no, I don't want to store like that. I'll have garage. I won't store parking as a row in the garages. I'll create a new table altogether. Okay. And every garage will have its own fare, right? So fare small vehicles, fare medium vehicles, and fare large vehicles. Then next is parking. That will do one thing. Yeah, there we go. Parking. Every parking will have its own parking ID. Array. Then what kind of vehicle type it can take? Is it medium, small, or large? And status, whether it's not set occupied. So this will be a Boolean value, whether it's occupied or not. Yeah, this looks good. The way this looks good, basically all these databases will go. Oh yeah, let's add a users table as well, right? Users, user ID, username, just like I mentioned, but I'm not storing the first name, last name for now. Email, password, encoded, and what else? What else? What else? Vehicle type. So what kind of vehicle the particular user has. Yeah, this should be good. So let's go to the design stuff and understand how we can design this parking system. We'll first have an actor. I'm not going to write that heading and whole thing. Requirements, right? We already went through the requirements, right? So actor, okay. This guy will. Do we have any kind of an item thing? As in like a actual phone or something? Excuse me. We don't have it. I wish we did. Settings. Anyways, so this particular actor will interact with the mobile app or web app. Hmm. I don't know how to. Yeah, there you go. So this particular person will act with the mobile app or the web app, and then from there, what will you do? It will work with a backend app service. Backend app service, okay. No, wait. We should have a load balancer between this. Load balancer. Now we have maintained everything. Load balancer, rate limiter or whatever. Then okay. Now since we have multiple APIs, let's talk about the endpoints itself. Okay. So what are the endpoints first? Let's go to the endpoint thing. We had the reserve endpoint. Reserve is a write endpoint. Okay, let me quickly mark all the right ones with green and red ones with orange. So reserve is a write and wait, yeah, write endpoint. Payment is a third party kind of a write endpoint. Cancel is also a write thing. Create account is write. Login is read. Calculate fare is read. Calculate fare is read. Calculate fare is read. Login is read. Free spots is read. Allocate spot is write. No. It gives garage ID gets a return, right? It's no, it is a write because I'm writing particular spot. Okay, good. So we will have these endpoints going to different databases. And these are the databases. Let's create the databases first. Let's create the databases. First was reservations. Reservations. Next is what is this? Garages. Parkings. And actually, I don't think we will need so many databases, right? You can have a single database which will have multiple tables. Reservations, parking, sorry, garages, and parkings. So this is the database. Now, we'll also, if we have a read replica, let's also have a write replica. So this is the write replica. Okay? Write, got, right, or whatever. That was weird. And this is read. I'll just do it like this. Okay. That is the write replica. This is the read replica. App service, backend app service needs to write to this endpoint, so to this database. We can have different microservices, right? Basically, wait, this will handle different microservices. One microservice is for account creation. Then one microservice is for what is this thing? Reservations. All these are right. Okay. Or I can just call this account microservice. Account MS microservice. Reservations microservice. This can do both write and read. And then there is one payment microservice, which is third party. So the backend service will basically interact with all these backend app service. Let me actually move these three up down. There we go. So this interacts with this. Yeah, this is much better. So, and this is the reservation thing. And there's another one. Okay. Look. So all basically payment would have its own database. We don't need to worry about that. And account will check the database. It will also have users. Sorry. Nice. And since this is a read replica, we'll actually have some kind of a database like replica service, which will basically create a read replica. Okay. And since you need to make sure that it's highly available, or basically the data is consistent, we can maybe have 2-3 replicas if there are way too many uh, applications. It really depends on the requirement. I'll have one here for now. And so these microservices and basically backend app service will interact with the read one directly. So we'll have to, okay, actually, but it's better if these are um, write microservices, and we'll have a single read microservice. And since reading would like have a lot of requests, you'll basically fetch more data than actually reserve more data, right? So we'll also have a load balancer in the between. Load balancer. And this will basically read the data from this database. Yeah, this is a good one. So this will allow us to create a good parking system. If you have any questions for me, let me know in the chat, and I'll see you in the next one. Bye bye.